Welcome to Inside the OR, the Robotics Report. I'm Vivian Eason, and today we're going inside one of the most advanced areas of modern surgical instrumentation, robotic surgery. Robotic assisted surgery has changed the way many surgical procedures are performed. Robotic systems allow surgeons to control specialized instruments from a console while viewing the surgical field through a high definition camera system. But behind the technology is another important team, the sterile processing professionals who clean, inspect, assemble, sterilize, and prepare those instruments for their next use. Today's topic is robotic surgical instrumentation and the importance of proper processing and inspection. My thesis for today's podcast is proper cleaning, inspection, handling, and maintenance of robotic surgical instruments are essential for patient safety because these instruments contain complex and delicate components that can be difficult to clean, inspect, and maintain. By the end of this episode, you'll understand what makes robotic instruments different, what problems sterile processor professionals may encounter, and what steps can prevent instrument failure. Segment 1. Before discussing robotic instruments, let's talk about robotic assisted surgery. Robotic surgery does not mean that a robot is independently performing surgery on a patient. Instead, the surgeon controls the robotic system. Once commonly recognized robotic surgical platform is the Da Vinci system. The system includes a surgeon console, a patient side chart, robotic arms, a vision system, and specialized surgical instruments. The surgeon sits at the console and controls the instruments using hand and finger movements. The robotic system translates those movements into precise movements of the instruments inside the patient's body. This technology can provide advantages such as enhanced visualization, precise movement, and increased dexterity during certain minimally invasive procedures. The instruments are inserted through small incisions or ports called trocars. Unlike traditional laparoscopic instruments, some robotic instruments have articulated wrist like mechanisms. This allows the instrument tip to move in multiple directions. This articulation is one of the features that make robotic instruments so useful and also one of the reasons they require special attention during processing. So, what makes robotic instruments different from traditional surgical instruments? One major difference may have only a few moving parts. A robotic instrument can contain multiple small components that work together to create precise movement. Many robotic instruments have a long shaft, a distal wrist mechanism, small working jaws, internal cables or components, an instrument housing, connection points, and specialized attachments. The distal end of the instrument is especially important because it performs the actual surgical function. Depending on the instrument, the tip may grasp, cut, dissect, suture, or manipulate tissue. For example, robotic instruments may include needle drivers, bipolar forceps, monopolar scissors, graspers, and vessel sealing instruments. Because these instruments are complex, sterile processing professionals must understand that they cannot always be processed exactly like basic open surgical instruments. The manufacturer's instructions for use, or IFU, are extremely important. The IFU provides the cleaning, disassembly, inspection, sterilization, and maintenance. Let's look at a few examples. First, there are robotic needle drivers. These instruments are used to hold and manipulate surgical needles during suturing. Next are robotic graspers. These are used to grasp and manipulate tissue. These are also robotic scissors, which can be used for cutting and dissection. Another example is bipolar forceps. These instruments use electrical energy to help control bleeding. There are also specialized instruments for design for vessel sealing and other surgical tasks. Each instrument has a specific function and each requires appropriate inspection. For example, a robotic needle driver must be able to securely hold a needle. A robotic scissor must have properly functioning cutting surfaces. A robotic grasper must open and close correctly. An electrosurgical instrument must have intact insulation and functioning electrical components. This is why sterile processing professionals need more than instrument identification skills. They also need to understand how each instrument is supposed to function. One of the biggest challenges with robotic instruments is cleaning. Surgical instruments can become contaminated with blood, tissue, body fluids, and other organic material during a procedure. If this material dries onto an instrument, it can become more difficult to remove. Robotic instruments can especially be challenging because of their small working components and complex design. This is why point of use treatment is important. After the instrument is removed from the surgical field, appropriate measures should be taken to prevent soil from drying according to the manufacturer's instructions. Once the instruments reach decontamination, they must be processed according to the appropriate IFU. This may involve specific cleaning techniques, flushing, brushing, disassembly, or other manufacturer required steps. The important point is that cleaning must be effective before sterilization occurs. Sterilization is not a substitute for proper cleaning. If organic material remains on an instrument, it can interfere with the overall sterilization process. This is why sterile processing professionals need to pay close attention to the design of robotic instruments and the manufacturer's validated cleaning instructions. After cleaning, inspection becomes one of the most important steps. The sterile processing professional should carefully inspect the instrument for cleanliness, damage, and proper function. Some important inspection areas include the working end, shaft, joints, cables, housing, and connection points. The instrument should be examined for cracks, bends, corrosion, damaged tips, missing components, loose components, excessive wear, and residual debris. The distal working end deserves special attention because this is where the instrument interacts directly with the patient's tissue. If the jaws are damaged or misaligned, the instrument may not perform correctly. If a cutting instrument has damaged blades, it may not cut properly. If a needle driver cannot securely hold a needle, the surgeon could experience difficulty suturing. Inspection should therefore involve more than simply asking whether the instrument looks clean. The processor needs to determine whether the instrument is clean, intact, and functional. Another important consideration is articulation. Many robotic instruments are designed to mimic the movement of a human wrist. This allows the surgeon to make precise movements. However, that means the instrument's moving components must function correctly. During inspection and functional testing, the processor should allow the manufacturer's instructions for determining whether the instrument articulates properly. The instrument should not be forced. If an instrument feels unusually stiff, loose, or difficult to operate, it may have a mechanical problem. The processor should not attempt unauthorized repairs. Instead, the instrument should be removed from service and handled according to facility policy and the manufacturer's recommendations. This is an important part of sterile processing professionalism. Sometimes the safest decision is not to try to fix something ourselves. It is to recognize the problem, document it, and send the instruction to the appropriate repair service. Some robotic instruments use electrosurgical energy. Examples include instruments used for cutting, coagulation, or vessel sealing. These instruments require additional inspection because electrical safety is very important. The insulation helps keep electrical energy contained within the intended pathway. If insulation becomes damaged, electrical energy may potentially travel to an unintended location. That can create a risk of unintended tissue energy and injury. Sterile processing professionals should carefully inspect the instrument for visible insulation damage and follow the manufacturer's instructions for any required electrical or insulation testing. Warning signs may include cracks, cuts, burns, exposed metal, discoloration, peeling, and other abnormalities. If a defect is discovered, the instrument should not be returned to the surgical set. It should be removed from service and handled according to facility procedures. This is an excellent example of why sterile processing is directly connected to patient safety. Proper handling is also important. Robotic instruments should be handled carefully during transportation, cleaning, inspection, assembly, and storage. They should not be thrown into a sink, dropped into a hard surface, or handled in a way that could damage delicate components. When instruments are transported from the operating room to decontamination, they should be contained and handled according to facility policy. In decontamination, appropriate personal protective equipment must be worn. After cleaning, instruments should be handled carefully to prevent damage. Sterile processing professionals should remember that even a small component can affect the overall function of a complex robotic instrument. What happens when a robotic instrument fails inspection? The answer depends on the healthcare facility's policies and the manufacturer's instructions. Some instruments may be sent to an authorized repair service. Others may have specific maintenance requirements. The sterile processing professional should never make an unauthorized modification to a robotic instrument. Repair documentation is also important. Tracking repairs can help a facility identify patterns. For example, if the same type of instrument repeatedly develops the same problem, that information may indicate a need for additional staff education, changes in handling practices, or communication with the manufacturer. Instrument repair is therefore not just about fixing an individual instrument, it can also contribute to quality improvement. Let's imagine a situation. A robotic needle driver comes back from the operating room after a surgical case. During processing, the instrument is cleaned according to the manufacturer's instructions. After cleaning, the processor inspects it. At first glance, the instrument appears clean. However, when the processor tests its function, the jaws do not close evenly. Instead of ignoring the problem, the processor removes the instrument from service. The instrument is documented and sent for evaluation. This decision could prevent a problem during the next surgical case. Imagine if that needle driver had been returned to the operating room and the surgeon attempted to grasp a needle. The instrument might not hold the needle securely. That can interrupt the procedure and potentially create a safety concern. This example demonstrates why functional inspection is just as important as cleaning. So, what can sterile processing departments do to problems with robotic instruments? There are several important strategies. First, there's education. Staff should receive appropriate education on robotic instruments and their processing requirements. Second, follow the IFU. The manufacturer's instructions should be readily available and followed carefully. Third, proper cleaning. Staff should understand how to clean difficult to access area and components. Fourth, careful inspection. Instruments should be inspected under adequate lighting and with appropriate magnification when needed. Fifth, functional testing. Staff should verify that instruments perform their intended functions according to the manufacturer's instructions. Six, proper handling. Robotic instruments should be handled carefully throughout the entire processing cycle. Seven, documentation. Problems should be documented so that repairs and recurring issues can be tracked. And finally, communication. The sterile processing department should communicate with the operating room, the surgical team, leadership, and repair services when problems occur. These steps can help create a longer culture of safety. It can be easy to think of sterile processing as simply the department responsible for cleaning instruments, but sterile processing is much more than that. Sterile processing professionals help ensure that surgical instruments are clean, functional, intact, properly assembled, sterile, and ready for safe patient care. Robotic surgery demonstrates this very well. A robotic instrument may look small and simple from a distance, but it can contain complex components that require specialized knowledge. A missed defect can affect the surgical procedure. A cleaning failure can create a contamination concern. A damaged instrument can malfunction. And a problem with an electrosurgical instrument can create a potential patient safety risk. Every inspection is therefore an opportunity to prevent a problem before it reaches operating room. Today's key takeaways are: robotic surgical instruments are complex and require specialized processing knowledge. Cleaning is essential and must follow the manufacturer's instructions. Inspection must evaluate cleanliness, physical condition, and function. Articulating components require careful inspection and appropriate functional testing. Electrosurgical robotic instruments require attention to installation and electrical safety. Damaged instruments should be removed from service rather than returned to the operating room. Documentation, repair, education, and communication are all important parts of maintaining instrument safety. And finally, sterile processing professionals are an important part of the surgical team, even though they may work outside of the operating room. The work that we do behind the scenes help make safe surgery possible. Thank you for listening to Inside the OR, the Robotics Report. Today, we explore robotic surgical instrumentation and the important role sterile processing professionals play in maintaining these complex instruments. My biggest takeaway is: advanced surgical technology requires advanced instrument care. Robotic instruments can provide surgeons with precision and flexibility, but those benefits depend on instruments being properly cleaned, inspected, maintained, and prepared for use. As future sterile processing professionals, understanding these instruments and recognizing potential problems can help us support the surgical team and protect our patients. I'm Vivian Eason. Thank you for joining me on the Inside of the OR, the Robotics Report. And remember, clean instruments are important, but clean, functional, and properly prepared instruments are the goal.